I've split my talk into 3 sections. I've called them transition, tectonics, and mystery. To start us off, I took a photograph the other day from over near Leinster, from Kington. It was a bit of a dull day, it's not a great picture, but it works well as an introduction to this talk. And it's a view that I'm sure you all know. There it is. It's looking westwards towards the hills, towards Hargest, Radnorshire, and Russia. Because it was a bit of a dull day, I picked out the hills for you. There they are. I've also picked out something else. My black dashed line there is a boundary that we all see every day, but perhaps don't really think about very much. Beyond it, you've got the hills, and then suddenly you cross that dashed line and you're on the flat land of the Herefordshire Plain. They're completely different. Those of you who are gardeners or farmers will have noticed that up on the hills the soil is quite shallow usually, and it's grey. Go down onto the Herefordshire Plain, the soil is deep, better farmland, and it's red, sometimes bright red, quite surprisingly red. So you've got that contrast between the hills, mostly used as grazing, pasture, some arable, down to the flat red soil, which is mostly arable land with some orchards, especially suitable for growing orchards, hence the history of cider making in Herefordshire. Our job this evening is to understand what's underneath that. Why is it like that? And I thought that a good way to show you the rocks would be to drill a hole down through them and see what we find. So I'm going to do that, but I'm not going to drill the hole here. Instead, I'm going to take you to London, and we'll drill the hole there. There it is. It goes down through a very well-known set of layers that all have strange names. I'm not going to read them out, and I promise I won't test you. But I shall draw your attention to just one. This yellow layer here, called Jurassic. You've all seen Jurassic Park, the dinosaurs? The Jurassic period was when the dinosaurs lived. So those yellow rocks have got dinosaur bones in them. That hole that I've drilled is several miles deep. So if you live in London and your children want to collect dinosaur bones, all children want to collect dinosaur bones, you have to dig a very deep hole, don't you? What do you? There's something else about those layers, isn't there? They're all tilted. And they really are like that. I haven't drawn them all. So what you could do is follow that layer up and see where it comes to the surface. So let's do that. The answer is Oxford. All you have to do is put the children in the car, drive to Oxford, have a look in the fields. It's easy. What happens if you keep driving? Can you see that you get to older and older rocks, which have been pushed up from deeper and deeper under the ground? By the time you're in Hereford, you're in old rocks. No dinosaurs here. Our rocks are far too old. And I finished drilling the hole at this red layer here. You can guess what that is? That's the red rocks of the Herefordshire Plain. Why have I stopped drilling there? The answer is that at this point, the drill gets stuck. we've hit a really hard layer. All the rest of that stuff was quite soft. We drilled through that easily, but we've hit something hard now. It's called Silurian. It's there. It's this very hard bluish layer that I'm drawing here. And if you follow that up to where we are, guess what it is? That's the boundary which you've just been looking at. It's hard rocks, so it makes the hills. It doesn't erode. Above it is the soft red rocks that erode away very quickly. And that's that dashed line that I showed on my first photo. This is a cross-section. You can imagine it rather like baking a cake. It's a layered cake, and you put maybe some food colouring in the layers to give it some layers like this. And then, over millions of years, the cake has been tilted sideways like that. And the top planed off. So I want you to imagine what it would look like if you looked down on that cake from above. It would look like a set of coloured layers, wouldn't it? Coloured lines, coloured bands. That's what it would look like. And it does. There it is. It's the geology map of England and Wales. The section we just looked at was from London to Radnorshire. And you can see these are the layers that we drilled through in London. There's Oxford, we went to there. This green lane is these hills, these are the Chiltern Hills. These are the Cotswolds, Herefordshire Plain, up to Radnorshire Hill, the darker blue stuff. That's the geology of this part of England and the Welsh border. So what we need to do is have a closer look at our bit round here. So I'll come back from London now, I'm going to look at our bit. And I'm going to look at Radnorshire Hill. So I mentioned that these rocks are called Silurian, and this is the hard bit where our drill got stuck, makes the top of the hill, because it hasn't eroded away very quickly. Keep that view in your mind. There's Kington on the right, and Dunfield is just on the left here. If you keep the view in mind, that's what the rocks are. They're Silurian rocks, that's the name of this time in geology, and actually divided into three sections. They're called Wenlock, Ludlow, and Pridley, named after the first places where they were studied, back 100 years ago. Wenlock and Ludlow, studied in this area here. Pridley is near Prague in the Czech Republic. The Wenlock rocks underneath are quite soft, crumbly sort of shell, you can drill those easily. Then you've got the hard siltstone of the Ludlow, that's where our drill got stuck. And then on top of that, you've got the soft red clay that we saw down in Herefordshire. So that's the Silurian rocks of Radnorshire. I want to go on a field trip now to walk around them. Well, not now because it's dark outside, but we could do it using photographs, couldn't we? So let's do this. I'm going to start off on the right by walking around some sites in Kington. Then we're going to go up Radnorshire Hill, and then we're going to walk back down through the woods to Dunfield, which is there. Taking you on a school field trip. And we're going to start here. Very exciting photograph? Yes, it is a very exciting photograph. Because it's the secret to finding something very special. Just see where that road sign is there? Just round the corner, keep going, about 200 yards or a bit less further on. You come to a place that I call the Bins. It's called Rock Cottage, they usually often do it there as well. across the road from the bins and look in the trees just where the bright sun is over there. Just go and look in there. You can find fossils. In fact, that's the best place anywhere around here that I know for fossils. It's absolutely amazing. Every stone you pick up has got a fossil. Many different kinds. The most common kind is these. They're called brachiopods. And this slab which I've shown on my picture is on the table here. It's that one there. Brachiopods are shells. They're marine shells lived under the sea. People are surprised when I tell them that you can find marine shells up here. Was the sea really this high? No. The sea has never been this high. It's the land that's got pushed up. You can find brachiopods very similar to these on top of Mount Everest. The sea has never been that high. It's continental drift, isn't it? Remember from school, you've got Asia at the moment drifting one way, very slowly. India drifting the other way, a little bit faster. Crash in the middle, and push up the Himalayas. They're still getting higher. Something very similar to that happened here millions of years ago. The hills have eroded away now, we're just looking at the plains. But that's why you can find brachiopods up here. They've been pushed up. The earth movements that did that, there are some brilliant examples, two of them, on the other side of the road from here. If you go back to the bins, just at the bins, there's a wooden bridge over the stream. Go over the wooden bridge, turn left, and straight away you get to this. Some of you recognise that? Yeah, very well known, isn't it? This is the Ludlow siltstone again. This is the hard stuff where our drill got stuck. Look at the angle of those rocks. Really, really steeply pushed up. Just at the top of that cliff, just out of the picture up there, is where Kington Castle used to be. I was told by a chap in Kington that back in medieval times there was an earthquake here. And that's what pushed up those rocks and destroyed the castle. Several people in Kington have given me versions of that story. It's obviously quite widely believed. It's not true. The earth movements that pushed up those rocks happened in the Devonian period, 400 million years ago. That's long before there were any castles. In fact, it's long before there were any dinosaurs. But it's a good story. I like the story. If we continue along this path, it follows the stream, along the old tramway, you get quite quickly to Crooked Well, which I'm sure you recognise. Keep going along this path, which goes just at the back of the houses, and after about a quarter of a mile, you get to another wonderful rock exposure, a much smaller one. Some of you might recognise this. A small exposure like this quickly gets overgrown with stinging nettles and brambles and all that stuff. Somebody is looking after this. Somebody is keeping it clear. I don't know who that person is, maybe you're here. If you are, thank you, you're doing a great job. It's a beautiful exposure of rock. I don't know how clearly you can see it in my picture, but I've picked out a few rock layers for you. There they are. See there? Again, this is evidence of those earth movements. In this case, the rocks have been compressed like that, so they've been pushed up into what geologists call an anticline. In fact, they've been pushed so much they've split along that dashed line, which is a fault. Really nice exposure. That's still in the hard Ludlow siltstone. If we keep walking eastwards from there, we should quite soon come to those red rocks, shouldn't we? And we do. If you keep walking from there eastwards, you get to the roundabout by KVS. go over the roundabout, past KBS, and there's a footpath on the right-hand side across the field. Some of you will know it. It goes along the old railway track. If you follow that for a few hundred yards across a couple of fields, you get to this. See how different that is? That's the red clay that we saw on the earlier pictures. We've crossed the boundary. So, what did that boundary look like? We must have just crossed it. What happened at the boundary? Is there anywhere where we might be able to see that boundary? Because we must have just crossed it. So what I'm going to do now is I'm going to walk back through the fields, back to the roundabout, and just round the corner, we're back on Kington bypass. The roundabout is just out of the picture down there by Atrium, just round there. And I don't know if you've noticed, but there's a footpath goes up here. There's some steps goes up. All the way through those woods, for quite a long way in both directions, there are some small quarries. They are sandstone. That's interesting, isn't it? I haven't mentioned anything about sandstone. This must be something to do with the boundary, because we're in the middle. It's called the Downton Castle sandstone. Downton Castle is near Ludlow, and you can trace it all the way across. And it's a superb building stone, which is why it's often followed by a line of quarry. So that's something to do with the boundary. We're going to go now on that walk I just showed you up to the top of the hill. How many of you play golf at Radnorshire? Quite a few of you must. Hands up, golfers? Any? Few? Those of you who play golf up there, I'm sure, will recognise that view. It's from the clubhouse. My secret for finding the next site is to go up to the corner just there, where there's the second tee. There we go. Par 4, 309 yards. That's on the corner there. Just above there, right by the tee, there's a little bit of a track. There it is. And you can see the rocks on the right-hand side there, look. But you can't see them very well because we're looking on one. So what I've done for my next picture is to just go around the corner a bit and look back again. Looks like that. Taken on a lovely autumn day about a week ago. If you look in the bracken on the top here, you find the same Downton Castle sandstone that we just saw down at the bottom. Because it's tilted down, you see it at the bottom of the hill as well. If you look down here, we're back on the hard Ludlow siltstone with the brachiopoid fossils in it. There are not so many fossils at that site. It's not as good as Kington bypass. But if you look carefully, you can find a few. The interesting bit is in the middle here. If you look very carefully there, it might take you a while, but if you look carefully, you can find these. Which is a coiled thing. It looks like an ammonite, doesn't it? You know those big ammonites, those big coiled ones that you see in the museum? It sort of looks like one of those, the little one, doesn't it? But it's not. We don't have ammonites here. They lived during the Jurassic time with the dinosaurs. Our rocks are too old to have ammonites. In a minute, I'm going to tell you what that is. But for the moment, I just want you to remember that we've found it. So, that's the section we've just done. We saw the Downton Castle sandstone at the top, the Platyscisma shale, as it's called, in the middle, and then the Ludlow siltstones below. And we're going to walk down now, down through the woods towards Dunfield, and because we're on the hard rocks at the top, it's mostly Ludlow siltstone all the way down, almost down to Dunfield. The hard Ludlow siltstone on the right there, and then when we get down to the bottom, we get onto that crumbly layer that's underneath, that's down at Huntington. So that's what we've just done. That was our field trip. We saw that the boundary was something to do with this sandstone with the platyschism layer. That's the transition from these hard rocks to these soft granite rocks. So, what is that telling us? How can we interpret it? Well, I thought a good way to understand this would be to look at a more recent example. So I'm going to take you to Iraq, to the Persian Gulf. There it is. Most of the land around the Persian Gulf on this side and this side is desert. But there are two enormous rivers flowing to the Gulf from the top. They're called the Tigris and the Euphrates. They're huge rivers. They're carrying a huge amount of sediment. So consequently, the Persian Gulf is filling up quite quickly. It's getting shallow. I want you to imagine now that you've built a time machine. Not just any old time machine. This is a special one. It goes underwater. It's a time submarine. And it can go on land as well. In your time machine, turn the dial back just a few thousand years. Not millions of years, we're not going back to Siberia, we're just going a few thousand years back to when the Persian Gulf must have been bigger than that. More like that. Before it got so big. We're going to take our time submarine and put it at the red place there and go right down to the bottom. We're going to sit on the bottom. And the first thing you'll notice is that it's dark. Sunlight can't penetrate very far through submarines. So you have to turn the lights on. And when you do, you'll notice that the water is not perfectly clear. There's a very fine mist of particles coming down. They're from those rivers. As the rivers flow into the Gulf, carrying sediment, the heavy stuff settles out pretty quickly, doesn't it? But by the time the water's got down to here, all that's left is that very fine mist that settles down very slowly to make mud on the seabed. So we keep having to move our submarine upwards, don't we? Otherwise it'll get buried. We have to keep moving it up. Now, turn the clock forward a few thousand years. It's going to look something like that. The rivers are closer now. So the sediment that's falling on us now is thicker stuff, isn't it? It's not as fine. It's what we call silt. We're getting buried in silt now, so we're going to move our submarine up a bit quicker. Turn it on a few thousand years more. Now we're very close to the rivers. We've moved our submarine a long way up. So the thing you'll notice now is that it's light. You can switch the lights off because we're very near the surface. It's light, photosynthesis. We're surrounded by seaweed. There's loads of seaweed around us now. A few thousand years more, we're on the beach. People sunbathing. We're surrounded by sand. A few thousand years more. This hasn't happened yet. We've got in the future now. We're on land. Deserts, we're in a desert, but deserts can have rivers through them. The Nile flows through a desert, so do Tigris and Euphrates. So now we're on land, and the rivers that are near us sometimes flood, and when they do, they bring down terrestrial sediments, which are very often red because the iron in them is oxidized from the desert. Thinking of that sequence that we've just done in our time machine, now you can understand that, can't you? Look, we've got mudstone, fine particles, siltstone, heavier particles. We've got some sand, that was the beach, and finally the red clay, which was the terrestrial sediment. So it's a story of this area going from water, the sea, being filled up by sediment to turn into land. How did I know? How did I know about that seaweed? Seaweed doesn't fossilise, it's too soft. Fossils are hard things like bones or teeth or shells. So how did I know about the seaweed? Well, remember up at the golf course, we found Platyscisma. And I promised to tell you what it was. Platyscisma was a marine snail, closely related to the land snails we have today. Those in your garden eat your lettuces, don't they? The marine ones eat seaweed. I mentioned that the Downton Castle sandstone, you can make houses out of clay, but you have to turn it into bricks first. And that was expensive in those days, so they generally didn't. Instead, they built out of timber. And that gives us another very obvious feature of that boundary, which I just showed you. On the hills, we've got the stone buildings that we have up here. Down on the flat plain, we've got the black and white villages. Because there was no buildings there. So they had to do it. There is another contrast between the hills and the plain, which I can't explain. But I can show it to you. It's the place names. Up on the hills here, we've got names like Huntington, Kington, Kington. They all end in Tom. If you go down there, you've got Willersley, Webley, Titley. They all end in Lee. Like that. Isn't that interesting? I don't know what the difference is between these. Look, we've even got a Kinnersley and a Kinnerton. What's the difference between a Lee and a Ton? I don't know. Does anybody here speak Anglo-Saxon? I'm hoping that somewhere later in our sequence of talks there's going to be somebody that can explain this for us. Because I think it's really interesting. But I don't know what causes it. So that was part one of my talk. It was a school field trip walking over the top of Radnorshire to Duncan. The world does not finish at Duncan. We can keep going. Part two of my talk I've called tectonics. And we've just walked down through this wood here. We've got to Duncan. We're now on the Wenlock Shale, which is that soft, crumbly stuff I told you about. It generally makes good farmland because it crumbles up nicely, it doesn't have any stones. And then we come to something completely different. Stanley rocks. More familiar view of it there, with that wonderful old railway building in the foreground. Notice that the railway building is not made out of that. This is Downton Castle sandstone again. They brought it up on the railway from Kington. But the quarry at the back is completely different. It's hard, grey, solid rock. We haven't yet seen anything like that. To understand a bit more about it, I think we should go back to our aerial view and have a look down at the geology from above. We're in this region here. And I think you can probably see on the map there's a rather prominent lineament down there, isn't there? It's a big fault. It's called the Church Stretton Fault. And it's one of these ones that's moved horizontally, like the San Andreas Fault in America is doing at the moment. Millions of years ago, it moved a lot. Today it still moves a little bit, doesn't it? We get a tremor down now and again. Sometimes enough to bring a chimney pot down. Never enough to bring a castle down. And millions of years ago it moved horizontally, but also a little bit vertically as well. It did shuffle up and down a little bit. And in doing so, it brought up some rocks from deeper underneath. There's a view. On the right, we've got Herrick Hill, Rushock, and Hargest Ridge. That's the hard siltstone that our drill got stuck in. And then on the left, we've got these blocky little hills, Stanner Rocks, Wurzel Wood, and just out of the picture, Hanson Hill. These funny, blocky little hills. A complete change of topography. It looks completely different over there, doesn't it? A slightly more detailed map looks like that. You've got Stanner, Wurzel, and Hanton in the red. And I've also showed Old Radnor, which used to be a blocky little hill, but it's gone now. It's mostly on the M5, I think. And these dashed lines are branches of the Church Stretton Fault. It didn't just move simply like that, it broke up and broke into sections, which are those dashed lines. To understand those hills a bit better, I think what we need to do is to go back to London and drill that hole a little bit deeper. So there we go. I stopped at the Silurian before, didn't I? But now I've drilled it further down through the Ordovician and the Cambrian. And then at that black line there, the drill gets stuck again. This time, seriously stuck. We've hit something really hard. It's the Precambrian basement. If you follow this line up to where we are today, where we are now, what you find is that the Cambrian and the Ordovician are actually missing here. They were eroded away before the Silurian. So our Silurian rocks sit directly on the Precambrian. There were volcanoes here during the Precambrian, and I've heard it said that Hunter Hill is a volcano. Well, that's nearly correct. Not exactly, but nearly. So let's have a better look at Hunter Hill. This is back in the Precambrian, so we're going a long way back in time now. A volcano is formed from molten rock, that's the red stuff underneath, liquid under very high pressure. It will force its way through any crack it can find and explode out on top to make a volcano, like that, or the lava and ash. When it's stopped doing that, when it's gone extinct, it goes cold, the molten rock solidifies, in this case, into a rock called gabbro. It's a hard, very hard crystalline rock, and I've got a great piece of it on the table here. It's that big rock in the middle there is gabbro. The Precambrian was a very long time, and those ashes and lavas up there are quite soft. So it doesn't take long to erode them away. So back in the Precambrian, that would have formed a hill. Then some more rivers came, this time carrying quite big sediment. We're still in the Precambrian. Sandstone and gritstone, quite coarse sediments, burying the hill again. There were then some very serious movements on the Church Stretton Fault. This is continental drift, continental collision. The old name for this was continental doing plate tectonics now. Shifting of the church Stratton fault. It's happened many times, but it happened particularly during the Silurian. So now we're back to this mudstone and siltstone, which we looked at on Radnorshire. That's where they were. They were forming under the sea. The gabbro was faulted into a block that was still under the sea. And just west of that, a fault brought some of the gritstone right up to the surface. So it made an island. This was a warm tropical sea. We were near the equator there. Today, if you have a warm tropical sea and an island, you get a coral reef around it, don't you? It was exactly the same in Silurian. A coral reef grew up around that island. Then there was more tectonics. The Church Stratton fault moved again, shuffled stuff around again to give us what we've got today. We've just taken a walk over Radnorshire Hill. Now we can see Stanner Rocks and Hunter as well, and Wurzel. These are these blocky little hills faulted up now. And here's our Radnorshire, the gritstone faulted up. And this is the quarry. At the top here you've got Gore Quarry, quarrying the gritstone, very good quality roadstone. And down at the bottom you've got Dolly here and Strings, which are quarrying the limestone, which is what the coral reef has now turned into. And I've got some lovely coral on there as well from Dolly here. This is now quarried as limestone. So if you go down to Dolly here, and you go into the quarry there, you're actually walking through the old coral reef. That's what it looks like. That's inside a coral reef. That's the limestone that they're quarrying at Dolly here. The limestone is mostly used these days for aggregate, that means making concrete. In the old days, its main use was for fertilizer and mortar. To make both of those, you have to heat the lime. And amazingly, I don't know if you've seen this, the old lime kilns are still there. Those are the best two, there are several more. They've been beautifully preserved, and I'm glad that they haven't destroyed those. If you stand in the same place where I am now, just turn the camera around slightly, you see the modern version. There it is. The asphalt. Asphalt is a mixture of gravel and bitumen. The gravel from the quarry and the bitumen brought in. You heat up the bitumen and you mix it up with the gravel, and this is the machine that does it. It's a wonderful machine. I don't know if some of you, if you've been down there, hear it working, all the rumbling of those conveyor belts and the grinding of the machinery. It's a brilliant place. If you like big boys' toys, it's brilliant. That's the asphalt part. Go up to the top of the hill, and there's the Gore Quarry, something very similar. And amazingly, there is a public footpath through Gore Quarry. Those yellow barriers there are to stop you getting killed. And when you get to the top, the path splits. One goes that way, and one goes through here. Through that machinery. It's actually a public footpath. You can walk inside that machine while it's working. It looks like this. Can you believe that's a public footpath? You can walk there any time of day or night, even when the machine is running. It's amazing, absolutely amazing. Being up there at Gore Quarry brings me very conveniently to the third part of my talk. Richie, when you did the poster for this talk, you advertised it as, I think you said, Geology Rocks, and underneath it you put a subtitle which was Elements for Life. Well, I wasn't actually planning to talk about elements, but I do want to pick up on your theme of life. We've already seen the dinosaurs in the Jurassic period. There they are, there's the dinosaurs. life on land and under the sea. If we go back to the Silurian period, we talked about that desert, didn't we? The rivers flowing through the desert. During the Silurian period, all of the land was desert, because land animals and land plants hadn't been invented yet. So all the land was desert. The very, very first land plants were just starting to appear on that Silurian landscape. If you'd have walked around on it, the tallest plant you could find was called Cooksonia. And it was about the size of a matchstick. That was all that you'd find in the Silurian period. So prior to the Silurian, everything was in the sea. And the sea was teeming with life. So go down to the Ordovician and the Cambrian, you'd have loads and loads of life in the ocean. Go to the base of the Cambrian, and you find worms, trilobites, shells, complex multicellular organisms. Go down just a few feet further into the rocks, into the Precambrian, and you find nothing. This has been a puzzle to geologists for 200 years. Charles Darwin recognized this as a challenge to his theory of evolution. I think the church rather liked it, actually. You would expect that in the Precambrian there must have been primitive life, the precursors of the Cambrian stuff, the simple ancestors. But you do not find them. It seems that multicellular complex life, as complex as shells and worms and things like that, appeared very suddenly. When geologists say very suddenly, they mean a few million years. It's referred to as the Cambrian explosion, the explosion of life that seems to have happened at the start of the Cambrian. We do not know why. It is a mystery. Something happened that enabled life to get going. With nothing in the Precambrian. Well, it was. In the Precambrian there was bacteria and algae. Single-celled organisms, very, very simple life. Nothing as complicated. In recent decades, in several places around the world, they have started to find Precambrian fossils right at the top of the Precambrian. You would expect those to be the ancestors of the Cambrian animals, primitive ancestors of them. Here, the mystery gets deeper, because they are not. They are completely weird. They bear no resemblance to any modern life form at all. It's called the Ediacaran fauna. Ediacara is a place in Australia where some of these are found. And I've marked it in yellow there. It's the very top part of the Precambrian. And there's an example of a couple. The one on the left is about 6 inches tall. It sort of looks a bit like a fern, but when people study it, they say, no, it's not related to a fern. We've got no idea what it is. The one on the right, called Dickinsonia, well, that's just weird. We have no idea what those are. We don't even know if they're animals, or could they be fungi, or could they be lichens? They look under the sea. We don't know what these were. They are a complete mystery. And they don't seem to have survived into the Cambrian period. To look in a bit more detail, we would need to drill my hole a bit deeper in London, but we can't because I ran out of paper. I've got to the bottom. So I've copied it onto here as what we call the geological column now, but you know what that means, it's my hole in London. And I've shown you where the Ediacaran fauna is, just at the bottom of the Cambrian. So we know that something interesting must have happened here, because the Cambrian life got going. We don't know what that was. Something interesting must have happened here too, because the ediacarans got going. You do actually find a few of them lower down, but they become much more common at this point here. And we do have a clue for what that might have been. I wonder if any of you have ever heard of snowball Earth. Millions of years ago, there was a time when the entire globe was covered in snow, ice, like a giant ice age, that Earth turned into a snowball. In fact, it happened 3 times. There they are. Those are called the snowball Earth events. They're called Sturtium, Mariner, and Gaskiers. And I've shown you the dates of them. MA means millions of years. Those are the 3 snowball Earths. The bottom 2, very big, the Earth frozen completely. Gaskiers a little bit smaller, as I've shown, but still a serious ice age. And we don't know exactly what happened here, but it seems that Gaskiers did something to the sea. Maybe change the salinity a bit, or change the oxygen concentration, or something. But it's very prominent that at the end of the Gaskiers glaciation, you start to see these ediacarans. Why am I telling you? Does anybody here work at the quarry? Is it Gore or Dolly here? Hands up, somebody. No? No? Well, if you know anybody who works at the quarries, tell them to keep their eyes on. Because look at this. Dolly here and Gore are quarrying the rocks which are the right age, and they're the right type of rock to find ediacarans. It is not impossible that somebody might find an ediacaran at the Gore or at Dolly here. That would be a very important scientific discovery if they did, and it is entirely possible. Quite exciting, because it's potentially on our doorstep here, as you could find one of these things. Ice leaves very obvious records, doesn't it? Scratches on the rocks called striations, U-shaped valleys, remember from your geography lessons. So, ice is very easy to recognize for geologists. We know exactly when there has been ice on this planet. And the answer is almost never. Since complex life evolved in the Cambrian, it has happened only 3 times. There they are. The Ordovician, end of the Carboniferous, and now. Look at this big gap up here, Jurassic. No dinosaur ever walked on ice. There never was it. Today, we have ice at both poles. We are in an ice age. There is no such thing as a normal climate. The climate is changing all the time and always has been. But there is such a thing as an extremely unusual climate. And you can see that we're in one now. And I'm not going to tell you anything about it, because that is the subject of our next talk. Which brings me to the end.